Hello everyone, welcome to another problem solving session from chapter 27, which is actually the current and resistance. Problem number 45 from Halidar Walker. In this problem, there are 5 resistance are connected and the 3 battery source, which is actually that idle batteries. It means that there are no internal resistance of these batteries. Now they are in a combination of series and parallel. Now we have to find out that size and the direction of the current through each of these batteries. Size means the magnitude of the current. And we have to also find out the potential difference between the point A and B. Fine. So to solve this one, basically first we'll assume some arbitrary current through this loop. Actually, so this is, I can consider this is the loop number 1. Say that there will be the current, say that I1, and through the loop number 2 the current, say that I2. The direction of this current is basically the arbitrary. After doing this assumption, if I find out that the I1 and I2 are positive, then the current will move towards that direction. So that's mean that is clockwise direction in both the loop. But if I find out that current I1 and I2 or any one of them is negative, then current will flow in the opposite direction. That's mean it will be in the counterclockwise direction. Fine. Now to solve this one, I will use the KVL, which is Kirchhoff voltage law. It says that in a closed loop, algebraic sum of the voltage must be equal to that 0. Right. So this is actually that KVL formula I will use for that one. So what I'm going to do, I'm going to start from that point, goes around that path, and I will come back to that point again. It will make a closed loop over here. I'll say this is loop number 1 and this will be loop number 2. So fine, if I write down that formula for loop number 1, so what I'm going to in that direction, right? So this is the direction. If I move in that direction, then I can write, so it would be E1 positive. Why it is positive? Because I'm moving in that direction. Then this is my final and this is my initial point. So final point is positive and lower point is negative. That's mean lower potential. Initial point is lower potential and final point is the higher potential. So final minus initial, that will give me a positive quantity over here. Minus I1 into R1. I assume the voltage drop across that resistance would be negative. So that's why I write down minus I1 R1. Now for the R2, I have the two current. One current actually towards the downward direction, which is I1, and another current is the upward direction, which is the I2. So that's mean the net current would be difference of these two, right? Now since I am considering that loop number 1, I will give the priority of the current I1. So that's why I'll write down the voltage drop across the R2 would be minus R2 into the net current, which would be basically that I1 minus I2. Then minus it would be that E2, because right now I'm moving in that direction. So that's mean I'm moving from higher potential towards the lower potential. So that's mean that voltage difference would be a negative quantity. So that's why I write down the minus E2 and minus I1 R1, right? And I come to that point. It makes a closed loop, so that's why it would be equal to that 0 over here. Now you can simplify this one. It would be E1 minus I1 to R1 plus R2 plus I2 R2 minus E2 equal to the 0. Now if you plug in the value of R1 and the E1, so E1 is basically that given, which is actually that 2 volt. So E1 actually the 2 volt minus I1, I have to find out that value. So R1 is 1 volt, so 2 into 1 in that's with the 2 plus R2 plus R2 is 2 ohm plus 2 into I2, since R2 actually 2 ohm, minus E2 actually the 4 volt equal to the 0. Now if you simplify, then you will find out is going to be that minus 4 I1 plus 2 I2 minus 2 equal to the 0. So this is actually that equation number 1. I have to use this equation, so that's why I'll make a box over here and say this is equation number 1. Now for loop 2, I'll start from that point B, I'll goes around that branch and I'll come back to again that point B. It will make a closed loop for that second loop. Now I'm going to say that remove that direction. Now if I start from the point B, I'll first face that E2, that should be that plus, since I'm moving in that direction for loop number 2 right now, right? So this will be a higher potential, this will be lower potential. This is my final point, this is my initial point. So final minus initial, it will give me a positive quantity over here. Fine. Now for voltage drop across that R2, it would be basically R2 into net current. Since right now I am considering the loop number 2, I'll give the priority of the current into the I2. It should be the I2 minus I1. In the previous case, we write down I1 minus I2 because in that case I'm working with the loop number 1. Now I'm going to work with the loop number 2, so that's why I give that priority of the current I2 minus I1. That is the voltage drop across that R2. Now minus I2 R1, which is the voltage drop across the resistance R1 over here, minus E3 minus I2 R1 equal to the 0. That makes a closed loop again over here, right? Now if you plug in, or you can simplify one more line, it would be E2 minus I2 R2 plus I1 R2 minus I2 R1 minus E3 minus E2 minus I2 R1 equal to the 0. If you plug in that numerical value of E2 and R1 R2, you will find out that would be that 4 minus 2 I2 plus 2 I1, R1 is 1, so I2 minus E3 actually the 4 volt minus I2 equal to the 0. Now these 4 will be cancelled out, this plus 4 minus 4 will be cancelled out, is going to be that minus 2I2 1I2, and this is would be that actually that 4I2 plus 2I1 equal to the 0, or I can write say I1 from there would be actually 2I2, right? So this is say that equation number 2. Now I'm going to plug in that I1 value from equation 2 into that equation 1. Now equation 1 will be implies minus 4 into I1 actually the 2I2, it should be that 8I2 plus 2I2 equal to the 2. Then it's going to be that minus 6I2 equal to the 2, or I can write the I2 would be minus 2 by 6, right, which would be basically minus 0.33 ampere. So it means that I2 would be over here moves to the counterclockwise direction, right? Why? Because initially I assumed that I2 is flowing to that clockwise direction. Now I find out that I2 is negative, it will actually move in the opposite direction. So I can say that actual direction into the current would be in that direction, right, since it's a negative. And the same way I can also find out, say that I1, so that I1 would be 2I2, which would be actually the minus 0.66 ampere, which is the current into the loop 1, that will also moves into that counterclockwise direction, right? So actual direction would be towards that one. Since I find out I1 is negative, it will move to that counterclockwise direction. Fine. So this would be actually the current through that battery E1. They asked me to find out actually in question number A, size I find out, which is I1 magnitude actually that 0.66 ampere, and the direction through that E1 battery, it be basically that downward, right? Since the current through that, actual current through that the battery actually towards in that branch is that direction. So that's why the current through the battery E1 would be downward. So what I will write down in that case, the answer number A is size of the current through the battery E1 is 0.66 ampere, and the direction is downward. I'm writing in a short form, downward. Fine. Now that B is the C is through the battery E2. I have to find out the direction and that current. So the current through the battery I2 one current, which is would be that direction, which is actually the I1 actual direction, and the I2 actually direction is the downward direction, right? So in that case the net current would be I1 minus I2, right? That's mean the size of this current. So what I'm going to write, so that the C size of current through the battery E2 would be, so I1, which is actually that 0.66, I took only the size, minus 0.33, which would be basically 0.33 ampere, and the direction would be basically that upward, right? Why it is upward? Because your 0.66, which is I1, is the upward direction. This is the direction, actual direction of that I1, right? And this is the actual direction of the I2. So I1 is higher than I2 over here, so that's why net current would be towards the upward direction. So number E, what is the current through the battery? E3. Now the battery E3 is current actually that I2, which is actually the 0.33, and it is moving towards that upward direction, right? So through the E3, the current will be towards that direction, so that's why it will be basically upward direction. Fine. So number E, size of current through the battery E3 actually I2, which is actually 0.33 ampere, and the direction would be upward, because the actual current direction, which is that into the loop 2, actually that counterclockwise direction. So that's if it's counterclockwise direction, means the current is moving towards that direction. That's why the current through the battery E3 would be that upward direction. So this is the answer number F. Now that question number G, I have to find out the potential difference between the point A and B. So to find out that one, last I'm going to find out the potential difference between the point A and B. What I'm going to do, to find out the potential difference between the point A and B, I can go through any branch. If I go through that branch, so that's mean that one, and goes around and come again point B, I can choose through that branch, so that's mean through the R2 and E2, and I can go through that branch R1, E3 and R1 again come to that point. That in every branch the net potential difference must be are equal, because they all are in parallel connection. So that's mean if I go is that path or that path or that path, I'll find out the potential difference will be the same. I'll verify for you for two branches over here. So let's first let me do one thing. Let me allow to make this copy for you. I'm going to make the copy so that I don't have to. So first I'm going to, so I will start from that point A. I'll go that path, because the current through that E1 battery is that direction. So that's mean the point A would be the higher potential, right? And point B would be the lower potential. So if I write, I'll also use the KVL over here. Say I'm going to start from that, say that the voltage drop start from the VA minus I1 R1, which is the voltage drop, actually this resistor R1, minus E1, which is the voltage drop across the battery E1, minus I1 R1, which is the voltage drop across this resistor R1, and minus VV equal to that 0. Now I'm going to find out, say VA minus VV, that I have to find out. It would be basically 2 I1 R1 plus E1, right? So what I can write, VA minus VV, 2 into I1, actually that 0.66 magnitude, 0.66, so 0.66 into R1 is 1, and E1 actually that 2 volt. So if you solve, then you will find out the VA minus VV would be basically 3.3 volt. So this is actually that answer number G. Or if you choose that different branch, say I'm going to start from that point, So I know the net current through that one actually in that direction, but I'll come in the opposite direction. So I'm writing the OR over here. Say I'll write down, say, the V1. Now this time net current through the resistor, say that net current through the resistance are actually that, say that I'm choosing over here, but it is upward. So I'll write in that case I into R2. I give the plus sign because basically I know that the voltage drop across the resistance will be the negative, but I'm coming towards that direction, but the current is the opposite direction. So that's why I give it the plus sign instead of minus sign over there. Now minus E2, I'm coming from higher potential to the lower potential, right? Minus VV equal to that 0. Now we can simplify. It's a VA minus VV would be E2 minus IR2, right? So now what will be the case? VA minus VV, E2 actually that 4 minus I is the net current through that branch, which is actually that 0.33 into R2 actually that 2 ohm, right? Then I'll find out, say that VA minus VV, which would be that 3.3 volt again. So that should be the same. So that's mean if you go any branch through either that one in the loop number 1 that way, or you can go in that branch, or you can go in that way, the voltage difference between that 2 point A and B would be the same. So that is the answer of that question number G. Okay, thank you very much.